Hello, everyone. My name's Ian Gray. I'm the co-founder of Craft of Architecture, and I'm here today with the main contractor, Bryson Co., who's represented by Ulrich Engelbrecht. I think the easiest always with architecture and buildings is to probably share screen. So I'll be jumping off and I'll jump between a couple of slides, but if I just share the screen, hold on one sec. And then is that okay? So, and Nicole, maybe if I can ask you if things aren't because this Zoom call actually doesn't have a circle around that big screen, but can you see the project brief on the screen?
We can, yes.
Okay, so our client is Fair Cape Group. This is Boulevard Office Park. And just to give everyone a little bit of perspective as to where we are. So it's located in Cape Town. Just to jump around, if you look, we've got Table Mountain in the background. And as you come into the city on the right, there's this quite a large and dense office park. And we weren't the architects. I think it was Derek Henstra, DHK, and Louis and Perutin that were the architects that designed various blocks. But we were looking at this courtyard in the middle, and the client has asked us to sort of create a more habitable space out of the existing courtyard. And if you I'll jump around through a few photos, but if you can see just this one photograph that I pulled up of the existing courtyard, it really was. And maybe because I had two different architects working on it and everybody thought about the actual buildings but not about the courtyard, it really was a windswept, barren courtyard. It's about 1,000 square meters, and the client asked us to come in and essentially make it more habitable. What you can see on the right is one existing tree in the whole courtyard, besides those couple at the back that hardly have any leaves on. But what is striking as you come into the courtyard is it's a steel building, steel and concrete frame, but it really is just this glass, aluminium, and these stainless steel railings, and then this massive amount of granite. And it didn't have a human scale to it, and it. Although there's thousands of people actually use the office park during the day, there's a lot of call centers. No one was really using the courtyard, and to the extent that sort of sprinkled some chairs around, and they were also in this windblown courtyard, and very few people would be using them. And so our approach, just to jump back to the presentation, I will just press that. So yeah, there you can see the buildings in plan, and I'll just walk through the actual presentation. I'm actually going to go to this slide first and just some of the things we were considering from an architectural perspective. So we felt like circulation needed, so there's the courtyard looking from the north, as I showed you on Google Earth. There's this existing building which housed coffee shops, and we really wanted the space. If you look at the courtyard, the spaces around needed to be retained for circulation. So we felt like we were coming into the center of the courtyard. And so that gave us a little bit of the ability to kind of focus more on the central portions of it. And then other things that were a factor, I've spoken, this is just a diagram showing the sort of green trees of the area. And although there's a couple of green parks around it, in the actual courtyard, there was one green tree. We felt if you're dealing with humans and wanted a human scale, that planting was critical. So we worked with a landscaper to introduce planting into there. So that was our first step. This diagram shows looking north is straight up on the page, but these arrows indicate this southeast wind. And if everyone knows Cape Town, I think they say that God actually made the wind in Woodstock. It's where it originated. But the wind comes channeling through these two corridors that were created by that, by the placement of the buildings to the left and the right. And so whatever we did, we wanted to turn our back on that wind that was coming through. And that's also sort of helped in this diagram. If we could turn our back on the wind, you perceive this courtyard, this is the entrance into it. So we felt that whatever we did that turned its back on the courtyard would also be a sort of framing element to that courtyard, and we'd see it in the distance as you walked into the courtyard. And then this is a sun diagram. North is to the top of the page, but basically the buildings surround this, and obviously north, the sun beating into this courtyard onto that hard granite was very much something we needed to solve. And so whatever we did as an intervention would need some sort of roofing and allow people the ability to sit underneath some sort of canopy. The same with traffic noises, the freeway close to it, but we did feel that whatever we did in terms of solving and creating this backing to the wind would also solve the traffic noise. And obviously landscaping and trees do a lot to assisting with that. So just, sorry, jump in slide. So just, our idea originally was there's also a massive amount of granite slabs, like granite tiles, nearly 1,000 square meters. And we felt it would be really difficult to come in budget-wise. We were working within the constraints of quite a tight budget to just take the entire courtyard and just redo it all. So we wanted to work with pockets within it that could ultimately use the existing floor and keep the floor as it was, give or take a few areas where we would intervene. And the idea was that we had this planting, the seating, the benches, and then these vertical elements that turned into the roof material that would end up creating the shade and the pockets for people to sit. And so the idea of this ribbon that meandered through the courtyard became the sort of key element of the design. So just to flip through, sorry, I don't know why I did that. So the initial concept, if you look here at the slide that's on the screen, you can see the extent of the courtyard and all the granite. So you can see how we used like various pockets within that so we could keep a lot of the granite intact, and then we created these little zones within where people could congregate. If you look at the slide, I think, you know, we're obviously today talking about the steel elements. And it's interesting because I showed you that first slide, and it's an interesting choice of material that we chose steel because we were trying to get away from the fact that there were these cold elements of the glass, the stainless steel railings, and all the aluminium, that we chose steel. But originally the idea was that we would introduce a warmth or natural element to the steel by using a Corten or a kind of rusted look that would be very much contrasted with the glass and the grayness of those existing buildings. So just by nature of it being more earthy, it would tie in with the planting that we proposed. Over time, there was a lot of concern, and we'll talk about the sustainability elements of the steel later on, and the maintenance of there, but the client became really worried about this Corten steel, how it would weather over time, and also how it would be in terms of people leaning up against it. So we ended up choosing warm colors for it, which ended up being quite successful, and contrasted quite a lot with the existing colors. And then you also see in the slide just talking about other architectural elements, but there's these timber benches, which they were also worried about the maintenance, and ended up being polished concrete, but you could end up seeing a lot of the stone, and they were warm grays, which ended up also giving it a more natural appearance to the glass and everything else we were talking about in the office block. And then really the essence of it is about the planting. And we almost felt like the steel and these canopies needed to become not the element in themselves, but they were combined with the planting, but they didn't need to take center stage. They all three needed to work together. And that was kind of where the idea of the ribbon was really successful, because it grew out of the planting, and then the vertical elements ended up turning into the roofs as well. So, and then, you know, just by nature of the way we designed the plans and the vertical elements, it all hopefully tied together as one sort of cohesive sculpture within the center of the square. Yeah, so just, I think we'll show you the design and get into all things practical, but just some of the more specifics. We completed it last year, around about this time in the middle of winter. The total cost of the project was 3 million Rand, which we think is really successful in terms of how much value engineering needed to go into the project to create an installation that was actually, if you think about it, was 1,000 square meters of courtyard that we were trying to do a design for. And if you calculate what that cost is, it's, you know, we did an urban design for around 3,000 Rand a square meter. So I think that's really successful. The type of structure we'll get into, but it's tubular, and obviously the feature of the structure is, you know, it's architectural, and it's an institutional building, public buildings, and it is very much a public space used by everyone within the building. So I've spoken about everything here. You know, these are the points I was speaking about, but this is just the entry as we gave it to you. I think the only last thing I'd like to add here is this bottom paragraph. is just the real success of the project is actually how people use the space. And it's just, what's also interesting is so often when we work with steel, it's always of a larger scale, like these big buildings, these big spans, and it was just interesting for us as architects to use steel to make a more habitable, more personable space, which is actually quite intimate and detailed, which isn't always the way steel is used within our studio. So yeah, if I jump to the next slide, these are more practical things. Ulrich, at any time you want to step in, but there's the actual cost of the actual steel within the project, the tonnage, 6.2 tons. And then these profile we use was the square hollow sections and the flat plates, which we'll show you photographs. And here's the first sort of imagery you'll see in this presentation of these angular forms. And I think what ends up, we'll talk about it later as well, you can see the planting and the angular elements of the concrete, but the steel elements ended up being these kind of iconic sculptural forms. They're quite striking as you come in. They end up looking more, we would like to think, like pieces of art within this courtyard than actual buildings themselves. The structural engineer, unfortunately, Jacques couldn't be here today from Devs, SAISC, and then we've spoken about the contractor, the detailer, Trident Steel, and the merchant, Stewart and Lloyd, and paintwork contractor is CP Painters and Decorators. So these are your questions, and we'll just jump to them, but give a brief description of the structural framing and how does this project illustrate the benefits of steel as a material. And without the structural engineer, maybe trickier to explain some of the load path and bracing system, but I think it's also fairly self-explanatory. So here you see the frames, and essentially they're these hollow square sections with these plates, which we'll show you as well, that are welded on to give it this very much wing-like character. Yeah, so I think this probably best explains the design. As it says there, the load path is fairly straightforward, but it's quite a good section, which is just a hand-drawn, one of the early hand-drawn sketches. I mean, for us architecturally, it's all about this thin profile on the edge, but obviously we had a structure within. We felt it was important to, from a distance, to see the outside structure as sort of one element where you didn't understand how all of the tubular elements worked within it, but we were okay and comfortable that once you moved within these frames that the structure became evident and you would be able to figure out how these things were put together. But from a distance, we liked the idea that there were purely these angular plates that sort of floated within the space. Bracing, obviously, because of the angular forms, it was very easy to cross brace. Normally you'd be trying to put that system into a very modular and linear system, you'd be trying to cross brace, but almost by nature the design of all these various angles ended up bracing itself. Yeah, and then obviously the overall stability, all of this had to be tied back to these fairly slender points that ended up being tied back into the big concrete bases that were placed within the planters. Yeah. Ulrich, at any time you want to step in, but there is a section where we purely talk about the construction of it. But here you can see the tubular form and then the very thin profile. And also with our client, it was critical because of the concept that we showed such a slender form on the end, that was continued, and they really supported us in achieving it. And there you can see the internal structure and yeah, I mean, I think the pictures paint 1,000 words. But you can see how it was pieced together. This is for the engineer to explain, but I can probably talk to it. But what was most notable technically? Were there any non-everyday design challenges, and how was efficiency achieved? And if applicable, were complex connections designed and executed? And how was constructability considered during design? So I think, just this is efficiency and optimization. It was the total steel weight came to the 6.22 tons, and it was across 262 meters. And this mass was necessary to provide the required stiffness of those faceted plates. Constructability, we're going to talk about a little bit with Ulrich now. And then constructability considerations. I think they're talking about it here, but they recognized early that complex geometry would be difficult to transport and assemble as a single unit. So it was like a hybrid of what they produced off-site. And we'll talk a little bit about the construction and what was there. I think you're on mute, Ulrich. Are you talking?
Yeah, Ian. Construction-wise, constructing the framework, it's a bit complex, but we managed to find a guy also close to you in Woodstock, where the architect's office was. His name is Fitz, and he was the guy that did the shop drawings for us. And I kind of worked hand in hand with him on a daily basis, trying to figure out, because remember, there's nothing square, basically. There's nothing plumb. There's nothing level. It's all angles and degrees and so forth. So his drawings worked out very well. We were like 90% spot on with manufacturing from the drawings that the shop drawings that he issued us, and with setting out on site with the plinths is where the legs gets mounted to the top of the plinth onto the plates. The best option for me was to position the plates on top of the plinth, anchor them with the chemical anchors with our M20s 600 deep, and then mark out exactly where the leg is going to sit in the middle of the base plate. And then I had the string theory where I used to run pitch lines from point to point, center of the plate to center of opposite plates of each leg, and that gave me an angle and a true length of where the legs are supposed to sit. And I transferred that to what I had at the workshop, to the structure, the tubular structure, and I got my centers and my degrees, and that was spot on. So the time we got the structure to site, we had a crane, and as soon as we put them on top of the base plates, we were 99% spot on. And I spoke to the engineers beforehand, before we did that, because remember, they wanted everything as one piece, galvanized, basically no welding on site. But we had to come to an agreement that there was no other way of doing it but to weld the legs to the base plate. And then they gave us a specification, how to cover the welds, what they want, how we need to cold galv it, how many coats, and and whatever. So that worked out very well. And then once we had the structure up, just to minimize error, having to cut plates on site, trim them, we took measurements with our degrees that we had from the structure, and I sat with a guy called Adrian at SAISC Steel, and we worked out the plate work, the cladding, and we had no major offcuts or trimming or stuff like that. So everything worked out very well with cladding and putting down the structure on the spot where we wanted it. So
okay, and I think just to add and to kind of, so everyone understands that we obviously modeled this thing in BIM and we had all the angles, but you needed to provide shop drawings and to marry the two between what we wanted on a computer and what you were able to achieve on site is obviously super challenging. What's interesting, you said there, Ulrich, is also that you had a crane, but due to the client's budget, we could have a crane only in the beginning for the biggest of the structures, and everything else you manhandled onto the site, right? I mean, you're back on mute again, I think. You want to talk about that?
We can talk about that. Because of the structure and the weight, and we didn't want it to, because we had to cut it up in 3 pieces because of the galvanizing bar that was too small. Too small for the whole structure to get dumped at in one piece. So engineers gave us a cutting schedule and a parting schedule. So we had to sleeve. We had to cut. Basically had to manufacture the whole thing at one piece, and then we had to cut it up in 3 sections. and they had to sleeve it, re-drill holes, and countersink them, because remember, the cladding needs to sit flush on top of my tubing, so there shouldn't be any balls sticking out visible or whatever. So yeah, so we did that. Bolted the structure back to one piece on site. Lifted it up with a crane, dropped it, and it was spot on. Yeah, the plating parts. When the plates arrived, they were coated on site before we fitted them. They were coated on site once on a piece of plastic that we had to put down, and yeah, we started fitting them.
So that slide, these slides I've got on the screen actually might help you there. I mean, this is the actual structure arriving. One of them,
yeah,
being placed, yeah, as a single element.
That's correct. Yes. So we
and then trying to attach it to the base plate that is there we go. You can see it on the left. So that's where you're referring to lining it up to match those plates on the ground.
That's correct. Yes.
Let me just yeah. So let me help just go. If I keep within this list, or let me just see if anything else is. So we've spoken about the the geometry. These are some of the images. This is obviously in the left images in your not on site. That's at your factory where you're busy producing one of the frames. Yeah, and then maybe just talk to this image on the right, because we obviously had all these bolt holes. We didn't mind seeing the structure internally. As I said, we wanted to see the smooth face on the outside. If you look on that image on the right, to people watching this video, but the image on the right, we were quite happy to see the angular forms that we helped, that we thought that they tied in with the concrete elements below and all the angles we had. But you managed to get that seamless, showing none of the bolt holes or anything like that, which I think was
we've got M16 countersunk bolts. I've got like 1 million of them on there. So all the cladding on top, we've got M16 bolts countersunk, so that's flush. And then we came up with a concept because like you say, we wanted everything smooth. The weld must be smooth, nothing must show, bolts mustn't show. So we spoke to Jacques and we said, look here, we can hide all the bolts, the heads, and we can smooth out the weld with a very thin layer of body filler. So yeah, that's what we did. We covered all countersunk, just a little bit like a mil, 2 mil deeper than we're supposed to, and then we got the body filler over that, and our painters came and they sanded everything smooth, and we got the excellent result. After the painters came, and I mean, you can't see any bolts, nothing, but I promise you, there's 1 million of them on.
And anything, I mean, we obviously as architects wanted this very thin profile on the edge of it. We wanted it to appear like a wing. Any challenges there? Sorry, I'm trying to, excuse our jump in between. Yeah, I mean, this thin profile over here and this weld on the end is obviously very difficult to achieve.
Well, not really. We, like you said, we manhandled everything. And then we used like props. We checked up the plates. So I mean, we didn't have to stand there and hold it the whole time. So we checked up the plates, and with that degree going up to create that top edge, it was 100%. It just worked out perfectly.
Yeah. And there you can see the 6 mil plate on the outside. And just and that's okay. I mean, there were a lot of questions which we obviously have answered in our actual report that we've submitted. I think we're happy enough to. Sorry, I'm jumping through. I'm just reading any of their questions, Ulrich, in terms of us as a presentation. Significant technical challenges, you've spoken about it. Innovative engineering approaches. Let me just jump. So challenges and solutions. I think for us it was making steel still be used within the context of a human and habitable environment, and to make sure it didn't have a cold aesthetic, and we achieved that by one, the color, the warmer colors in the environment, and also integrating it with the planting and the steel. From an engineer's point of view, their challenges were this seamless monolithic form, and they required all these structural connections to be entirely concealed within the faceted geometry. And achieving this meant managing incredibly acute angles where the panels meet to form the edges. And they had to ensure that the skeleton provided enough surface areas for the plates to meet precisely without any visible bolt heads or chunky plate overlaps. And then obviously this geometry was central to the challenge because of the structure. It just wasn't in in a linear grid, and every junction required unique geometric consideration. I think you've spoken about some of your challenges there, Ulrich, but I don't know if you can read the screen, but if there's anything there you want to talk to regarding this.
Let's see if I can.
Can you read it? Or is it can you see?
Not quite
I think you've spoken about I'm just flipping through, you've spoken about the seamless finish on the welding joints. Obviously the practicalities of installing this, just the scale of it as a single piece and single element we had to get in there onto these foundations. Yeah. So the benefits of steel, if I keep going with this, I mean, for us as architects, obviously the steel just was this very slender, very slick, sort of iconic form within the space, and there's no way we could have achieved any of these angles with all these slender forms in anything but steel. So I mean, it wasn't really, when we came up with the concept, there wasn't really an alternative element, material we could have used. Just concrete might have got us the angles, but we would never have got the thinness and slenderness to it. And we didn't want some heavy material in the middle there. We wanted these to be like this artistic sculpture within the courtyard. So we felt concrete would have been too heavy. Timber wouldn't have weathered with time, and we wouldn't have got the span. So for us, it was a no-brainer. It needed to be in steel. And I think this structural engineer obviously supported that and knew where the vision lied. And then the benefits of steel in terms of construction. I think we had the dream and Ulrich had the nightmare. But I just think lastly, just steel. This is a windswept, sun baked courtyard in the summer, and in the winter in Cape Town it rains for the whole time. So steel is just, the plants are going to survive hopefully within that courtyard because they're designed to do it, but the rest of this thing is concrete, polished concrete and steel, and we feel like it's going to stand the test of time and look as good in 5 years as it does on the day we installed it. So I think that was the benefit of using steel. I've spoken about sustainability. Cleaning is super easy at steel, and I suppose over time, if it ever's looking weathered, we have the ability to repaint it. And then lastly with steel, maybe was just, this is a functional courtyard, and I say there's thousands of people, well, close to 1,000 occupy this building. Like, it was super helpful that we were able to manufacture so much of this off-site and then bring it to the site to be able to construct it in as quick a time possible. We did a lot of those bases, but once, and that was slightly disruptive, but the steel work could be done off-site and brought onto site, which you can't do with many other materials. There's just some more imagery of it. You can really see the angles on that image on the right. You can see how it creates the shade and a sort of barrier to the wind, and it speaks for itself. And I like this image because you can see the smoothness of the outside flat panels. And you can understand the structure when you come within the spaces and you sit within them. But from a distance, we really wanted these angular forms to just be this sort of sculpture within the the center of the courtyard. What we're proud of, I think for us, it's architecturally, is that people are using the space. I mean, that's when you go there, everyone's sitting underneath these steel structures and within the courtyards and the plants, and that we took a courtyard that was barren and it's now serving its purpose of being a functional, habitable space. And Ulrich, I don't know if you want to speak about what you're most proud of in this process to the panel.
Well, I'm proud of the outcome of it. Like you said, it was a space that nobody actually used, and now people are using it. They get to use the space. Well, I'm proud of my team. We worked very well together. Everybody clicked. Everybody was hands-on.
And I think the other thing I'm quite, normally you can do a drawing in an architectural office and you can send it to site, and there's not that much complexity to it that you guys who building it and our team in the office don't have to have this massive collaboration. But obviously this was quite a brave and bold concept to begin with, and there's no way without the collaboration between all these various people, between you, engineer, and the guys on site, and even the painters and everybody else who were trying to pull it off. It really needed to be a collaboration, and I think that's quite unique, and it's not always the case in the construction industry. So I think we're quite proud of that as well.
Yes, I am. Yeah, like I said, if we had any small issues, I would always that's my main thing. I call the engineer, I call the architect. I say, look, what do you think? You're the guy designing it. You know what you want. So this is what I suggest. Are we on the same page? What do you think? And I mean, Clement used to come out, and Matthew, and we would chat, and they would always be like, okay, we're happy so far. That's my thing. Are you happy? You happy? I'm happy. So they would say, okay, that's cool. Docs happy, engineers are happy. And once I get the go ahead from them, the guys get involved here. They are happy. Everybody's happy. Let's just carry on. This is the solution. Everybody on board, and then we do what we have to do. And that's what I'm proud of. I'm proud of my team. I've got the best team to work with. From the guys helping me setting out to the painters, end result, the guys standing their butt off, getting everything smooth and ready for the painters. And yeah, came out very well.
Okay, I think that's it. Steel Awards.